Hello, and welcome back to Learning with Lee. In today's episode, we're going to do a bit of a review of what we've covered in the previous couple episodes by examining how we would convert these functions related to linked list into methods within linked list itself. To begin with, let's start off with append, and this is going to be a fairly simple, straightforward set of changes because most of these are going to be just categorized as a few things. We change the declaration here. We're going to modify the definition and some of how we actually are using it over in here. And then we're going to be affecting the places where it's being used. So let's copy append from here and move it up to here. So we're going to want to have this be a public method here. We do not any longer care about this list here because this was sort of our target list, with the other one being our source list. And now we just want to be able to append the source list onto the current list. So over here, we can get rid of this right here, same as we did in the declaration when we moved it in. We also need to change this so as that it happens to have, once again, the linked list right here, so as it's treated as though it's within the linked list class. So we no longer care about this one here. We care about whether or not our first item is a null pointer or not. And we care about the same stuff related to the source, so that's all fine. Now we no longer really need to have this target start since we just access first item directly. And we can just do that. So as it just is replacing that with that, and replacing this with that. And that still is clean. And then we do our count plus equals the source's count. Oh yes, and up here, we need our first item, previous item. And there we go. And that's literally all the changes that we actually had to make to this to get it to work. Now, right now it presently is still complaining that it can't find declaration of it over in here. However, that happens to be the sort of thing of once we build it, it should be able to find that declaration of it, since we're in the correct namespace and we're in the correct class here. So then, after we do this, we're going to need to head on over. Oh, I forgot to save it. That's why I can't find it. Okay, yep, that fixes that. However, now in linked list sort, well, actually, append is being used, for merge. So down here, what we just do is now a list, and then the little arrow in order to say that we want to access one of its members, and we want to append the B list to it. So that happens to be perfectly good for that. And that's really all we ever had to do for that one. Then generate random list. This one here is going to be a bit different. We're going to skip over that one for now, because that one has some special situations related to it. So then we can copy our inserts down into here. So we have this one here. We no longer care about the list pointer for it. And I'm just going to do both of these inserts at the same time because it's relatively easy. And we're just going to deal with them one after the other. Because in each case we know about the list that we care about. So let's just head on down. And actually I'll be reordering this in a little bit so that these are up at the top rather than being a little bit further down here because they're still at the same spots where they were with new list and delete list, but just to keep it all nice and alphabetized. So over in here, we want to insert. Within this, we need insert. We need to remove this guy, and I did save it over here so they can actually see that the declaration doesn't match current definition. There's that. And then we can do this, do that, do that, and you can see how this is really cleaning up a lot of our code, so as we don't need to actually go through as much of these references to the item itself, since we are inherently getting this one here, and we don't even have to have those parentheses there, since we no longer care about the order of operations. And that's all that we need to do for that one for now. We're going to have to do a little bit in a second when we get to some of the other stuff that's using it, such as up here, which actually, not a big deal, so do this, and then that should end up, yes, and have to remove that guy. And there we go for generate random list for now. That's going to be a bit different in a little bit when we get to there, but fixes the bug for now. Down here, this insert, get rid of that, make certain that we have it in the correct class. And this is one of those things that just is mildly annoying, but it's good to make certain that you always do that as soon as you make the change from something being a function to being a member method, that you want to have the actual class's name with the double colons before it. And make that change as early as you can. We get rid of all that. we just have a couple of link pointers, and we increase our count. And that's all we have to do there, though that's going to have some additional changes and impacts over in here. So pretty easy, though, to actually fix that of just copying that, doing that, and we're good. So now that we're done with those, let's move on instead to this Boolean of is sorted. And this one here was something that I had created for testing, just to make certain that everything was working. And we'll get into stuff such as debugging, unit testing, and how to properly test your code in the future. But for now, this just happens to use a list we no longer care about. That section of it, we do care about whether its first item is a null pointer. We do care about whether the count is greater than 1. Oh yes, and I also need, once again, because part of the problem here is that without having this class name up here, it's going to give you errors saying that it can't find these different items. As soon as I add that in, it's like, yep, I can find these, no problem. And fixes a whole bunch of stuff, allows us to go through there, and goes through and does that. Then, well, technically we're going to have to make a couple, well actually, no, because I'm no longer using that. That was solely used for some testing, so. Then, down in here, I have this, which once again, pop, no longer need the list pointer for it. And for this, we just remove this, get the first item. So long as link is not null, we then clean this up some. Oh, and yeah, that's always something that, at least for me, takes a little bit to get back in the habit of actually including this. And that's because in different languages have different ways of actually representing how you end up doing declarations and definitions, and we'll get into stuff such as C# and Java in the future with this. But we can just clean all that up, and that's really all you have to do in order to actually change pop to work, but that then, of course, breaks some code that we have up here, where we end up using that, and I no longer actually need to use passing in to this pointer since pop, because it exists within the same context of the class that the destructor for linked list does, it will end up automatically effectively passing in this as an argument without you needing to, and more or less having that same context of it. And I believe it is also then used over in here, yep. And the change once again is we just do blist and then this arrow pop. And that's really all we need to do for that one. Not to get too much into how we end up doing print lists, so I'm just going to skip over these two for now. And we'll skip on down to split, because print list is something that, once again, it's one of those issues of I wouldn't be looking to necessarily teach you guys yet about streams, input, output, string manipulation, and the different versions between C and C++, because there's a lot of information there, and it's too much to cover in an episode that isn't solely dedicated to it. And frankly, in probably multiple episodes that are dedicated solely to how you manipulate different kinds of streams. So, for now, let's just deal with split. We get rid of the source, since that happens to be the current linked list we're dealing with. Then down in here, what we can do is we can go, no longer care about that, only care about our count. There's that. Oh yes, and once again, need to copy this. And for me, this is something that I tend not to deal with C++ as much as I deal with C#, so that's something you don't have to do in C#, so it's a bit different. And there are some other differences, so just is something that I tend to leave out initially. Overall, it's largely going to be the exact same other than removing these references to source in here and just using the items that we had previously. So that's all that it takes for split. Now we, of course, need to change it up in here so that we use our list to actually split the into it in the split list. That changes pretty much everything there. I believe we're going to have to, well, actually, let's see. There's that. And merge sort, yeah. That should all be okay for now. Realistically, if I convert print list into a member method, that would be about the only thing that I'm really missing for being able to properly go with making this private for these three here. Because otherwise, if I do that and I try to build it, we're going to get some errors about things that are trying to use count and first item and the comparison. For the majority of the errors that we ended up getting, they came from two different things. The first was that up here, because of the fact I had not yet declared what the class for link and the class for linked list were yet, I had to use the keyword class in front of it. Now, the important thing to remember is that just because I had to use it in this case, doesn't mean that you would have to use it elsewhere, such as in the event of where I end up creating my new random linked list up here, I can use just new linked list, whereas if you remember in our previous implementation, when I had to malloc a struct for a linked list, that ended up requiring me to use the keyword struct before linked list. I couldn't just say malloc and then in parentheses size of linked list. I do size of struct linked list. And as a result, that ended up making our stuff a lot uglier. In this case here, if I had done something such as copied this up here, done that, in order to say that I'm effectively going to be using this in the future, then I won't actually need to have this one here. However, it's a bit more condensed, a bit more concise to do it sort of this way with then this down here for how we're actually dealing with it. The other issues that we ran into for that build were primarily related to this conversion of these three to private. And the bulk of those managed to be fixed by creating these accessor methods. And what accessor methods are designed to do is they are very lightweight methods that just have basically a single thing of returning whatever the corresponding private variable is. And the primary purpose of them is so as that other things can use those items and the like without ever actually having to have the ability to modify them. Because if I actually give them this item itself, then if they make a change to it, or if I have this public for this, then they could say that they have a link named A. I could go link and then do the little arrow deal, followed by item, and I could assign it any value I want to, whereas in this case, they can only end up assigning that on creation, as well as then they can then get it. And even though in these cases here we're dealing with pointers, because of the way in which the return statement works, for these types, it's returning a copy of that pointer. It's not returning that pointer itself. So when somebody calls getNext, they aren't actually getting the same pointer that is used by next item. So you can think about like this in terms of our earlier example of mailboxes. In one mailbox, I have a reference to another mailbox in my array of mailboxes that is my memory. And I can give somebody else, basically tell them, go look in that mailbox and give them the number for that mailbox. However, I still retain my copy of it, and I'm not giving them my copy that then they could end up changing, they could erase it, they could modify it. So that's the important thing to understand there. If I were to give them my copy of it, I would have to do something along the lines of going with a link pointer like this and return the address of the next item. And that would be the change you would have to make to actually do that. Now there's a couple more errors, and we're going to cover these in the next episode because how we fix them is a bit different. And it has to deal with why I didn't want to deal with some of the issues related to, in particular, this generate random list down here. So we're going to take a look at generate random list, append, as well as also split. And in particular, we're looking at the errors with append and split, because the solution to these problems is the same sort of thing that we're going to do to convert generate random list from a function to a member method. And for that, I'll see you in the next episode. Thank you very much for watching. Have a wonderful day.